Good morning, everyone. Oh, you can hear me, I can hear me, so I guess you guys can hear me. Welcome to the Cleanroom Technology Conference in Birmingham 2023. It's being run in conjunction and associated with Manufacturing Chemist Live, so there are dual talks going on. If you wander all the way around there, they're right behind us over there. If you want to go and listen to those, there's some information in your program about the timings of anything that they're doing that's going on in there. So just a quick introduction from me. So my name's Steve Ward. I'm the Managing Director at Valid Air. I've been in the cleanroom industry for 33 years now, so yeah, quite a long time. I was a cleanroom tester when I originally joined the industry, and I've had a variety of roles since then. I'm also the chair of LBI 30 Cleanroom Technology Committee. That's the BSI committee, so international standards. We work with the development of international standards, European standards for the cleanroom industry. I'm a technical expert, so I represented the UK for the update to Part 3, which was in 2019, issued in 2019. Part 4, which was issued at the very end of last year. I'm working on Part 7, which is separative devices, and that started last year, working on that. And I've just been working on Working Group 15, which is particle counting techniques. So I've been involved in quite a lot in that international working platform with the working groups. I'm also secretary of the Contamination Control Network. So that's a not-for-profit society in the UK, providing training and knowledge and various support network for the contamination control industry. It's free to join, so if you want to join it, you just go onto the website, just join up, and it's a great network to be part of. I think we've got over 400 odd members now, which is really good. I'm also a committee member, trainer and examiner for the CTCBI. That's the Cleanroom Testing and Certification Board. We provide training and examinations for cleanroom testers. So that's a bit of me, of my history. So this event can't happen if it isn't for a number of people involved in the project. So our sponsors, it's important to shout out to Redditch Medical, Micron, Clean, Wyss Technic, EECO2 and OPEC. So they've been out there, our sponsors for this event. So we're grateful to them. Also the organisers, HBCI Media, Ali and the team. Again, it wouldn't happen without these guys organising it. The audio-visual team here today will make this hopefully all run nice and smoothly, and Darren sitting in his box over there should make sure you can hear everybody, and it should all go really well. So the facility hosts here at the centre is really great, so appreciate to them for letting us host here again. This is 4th year now on the trot that we've been here, so that's really great. The caterers will provide refreshments and lunch, and in previous years that's always been pretty good, so hopefully this year they'll shine again. And finally also our exhibitors and delegates. So the delegates are you guys, so this wouldn't happen if you didn't show up. So thank you very much for showing up, and I hope you enjoy the next 2 days. And please go and visit our exhibitors. They're out in the halls out there. Visit them during the breaks. There's 2 refreshment breaks and a lunch break. Get out there, go and see them, and then get back in here for the talks as well when they're happening. So a quick piece of housekeeping as we keep going. So there's no planned fire drill this morning or fire alarm test today. So if we hear a fire alarm, it does mean that we need to evacuate the building, and there are fire exits and well signposted throughout the area that we are. So if you hear that, it's just out into the car park to the muster point. Toilets are downstairs, if you haven't seen them already. So as you go out into that main area, you go down the stairs, and the toilets are all based down there, and there's a cloakroom down there as well. And as I said, refreshments there'll be a break partially in the morning for tea and coffee and refreshments, and then there'll be lunch, which today is relatively late for lunch. I think it's about 1:45. And then there'll be a refreshment break in the afternoon as well. So as far as the exhibition is concerned, that's out in the 2 halls out there. As I say, please go out, go and see the exhibitors, talk to them, see what they've got to offer, spend some time with them, and then just get yourselves back in here for what's going on in here. If you want to take photographs, feel free to take photographs. Don't have the flash on your phone. But I believe all the presentations and slides are available to anyone who's here afterwards, so you can download that information later, so you don't need to be clicking on every screen to make sure you get that information. That will be available to you. To keep your phones on silent, please, just so it doesn't distract the speakers. It just can be a bit off-putting if the phones go off in the middle of someone talking. And And social media, post stuff on social media. It's 21st century. We should all be posting stuff on social media. So you're here, you know, whatever it is you do on the social media things, and let everybody know you're here. So we've got 2 days. So today's got quite a busy program today. Very shortly, John Halling will be doing a talk, and we have to special thank you to John. He stepped in at the very last minute because our speaker, who was due to speak this morning, is not here till tomorrow, so he'll be speaking tomorrow. That's Connor will be speaking tomorrow. So there's a slight change to your program, but John has very kindly jumped in and hopefully will give us an excellent week. And that will be followed by Jim Polarine from the USA, who's joining. He'll be doing a great talk for us later. And then we've got a number of other people joining us during the course of the day. So there's some really good talks looking at today. There's one really interesting one. So Duncan Barlow has identified himself as a microbial identification enthusiast. I don't know whether he's in the room. Is he in the room? He is. Hands up. There you go. And as a job title, I thought that was fantastic. So I think we should all go away and come up with better job titles than the boring ones we've got. So there's some great people talking today. It's really worth it. So I think it's after Peter. Yeah. So after Peter, there'll be a break. And during that break, there's going to be a live demo by Connector Cleanroom. So go to stand area C10, and there's going to be a live demo from Connector Cleanrooms in the first break. So it's worth going over and seeing. Lunch will be at about 1:40 today. And then the afternoon starts with Karen Rossington's going to be on and talk in the afternoon, and that will see us through the day. So slight change to the program with John stepping in at the beginning of the day for us. Also as well, at the end of the day, so once Alan Sweeney's done his talk at the end of today, there'll be a drinks reception, which is held out in the main area, a chance to have a drink, talk to some of the exhibitors again, and have a wander around. So it's a good thing to attend. So at the end of the day, pop into that. Day 2, there's a program for day 2. So Tim Triggs will be here on day 2 and be chairing. There's an excellent talk in the mid-morning from me, if you want to tune into that one. But there's another, so this is where Connor's moved. Connor's moved on to day 2. So in your program, he was shown as day 1. He's moved into day 2. So that's our program for day 2. And some really, really good speakers on day 2 as well. Definitely worth being here for day 2 and to catch those. Okay. The last thing I want to say is Cleanroom Technology ran a Cleanroom Technology Asia last December in Singapore, and it went really, really well, and they're running it again this year. So if anybody's got international connections or fancies a trip to Singapore, it's at the Marina Bay Sands Hotel. It's a fantastic venue. It was a really good conference last year, and so they're running it again this year. So 5th and 6th of December, if you want to scrape some pennies together and go to Singapore, it's definitely worth it. It's a lovely city as well, so that's a great place to go. So looking for exhibitors and also delegates to come along as well. Okay, that's it from me. I'm now going to pass over to John. There you go, there's a clipper.
So please bear with. I finished writing this last night about 9 o'clock, and I haven't actually given it a dry run, so I'm going to wing it. So what I'm going to do today is talk a little bit about the overall collective strategies involved regarding management of cross-contamination and the preservation of containment within a multi-product, potentially multi-occupier manufacturing facility. And my emphasis is going to be around ATMPs, so Advanced Therapeutic Medicinal Products. That's where I spent the last 7 years of my career. So we'll use that as a focus. And a quick word to Joe, who I think is the next speaker. I really hope I don't steal your thunder, because looking at the titles of the presentations, there's quite a lot of similarity. Okay, so what are we trying to achieve when we talk about the avoidance of cross-contamination and ensuring that we maintain containment? So really we're looking to try and do 3 things, 2 of which are, you could argue, mutually opposing, certainly when it comes to HVAC and pressure cascade strategies. So we're looking to prevent the ingress of any environmental, biological contamination from the outside world coming in. So all of the bacteria, endospores, yeasts and molds and viruses that are ubiquitous in our normal working environment. We want to keep those out. But at the same time, we want to stop those biological entities that should be within the clean rooms, the starting materials, the leukapheresis, the blood, the tissue samples that are the beginning of a lot of ATMP manufacturing. We want to keep those contained within a discrete clean room. And at all costs, what we want to avoid is a situation where the active biological material from one clean room suite manages to find its way into another. If you envisage a scenario where within a facility different clean rooms are manufacturing cellular products, that could be autologous or allogeneic, and viral vectors, you can understand that particularly from a regulatory perspective, there is a huge focus on being able to demonstrate that you've got the necessary controls to make that happen. Now, it's also fair to say, just to calibrate, that the actual risk of a loss of containment is extremely unlikely. We operate along the lines of layered controls, so we're not relying on one attribute or one approach to managing containment. We've got a stack of them, and they all have to fail, and there has to be an accidental release of biological material to realize that risk. So it's extremely unlikely, particularly as the vast majority of the processes that we're talking about they're closed. They're behind a discrete sterile boundary. So you need those two things: failure of the controls, and then a breach of the contained process. Okay, so as I mentioned before, we are looking at a cumulative sequence of controls to avoid the risk of the ingress of material into a clean room and the escape of biological entities that should be in there. Okay. So the control layers are numerous. If we start with considerations relating to the facility, we've got its architectural design, the way it's laid out, the routes of access and egress, unidirectional flows, the sequence of personnel and material access and egress routes and their interfaces. We've got all the monitoring we do, and this is really twofold. Firstly, our environmental monitoring programs, so that after the fact gives us a degree of assurance that the control strategies that we have in place are working and effective. And we've also got the real-time monitoring that we undertake with our qualified environmental management system. So the brain, if you like, of the control strategy around maintaining pressure, temperature, relative humidity, etc. So to an extent, we've got the fabric. That's in brackets because considerations for fabric are generally no different than any other aseptic or sterile manufacturing suite. So just the requirements of the updated version of Annex 1 all apply. And we've got a big piece around operations that we'll pick up separately. We've then got considerations for our HVAC design and the airflows that we adopt within our manufacturing facility. And then we've got our number one biggest risk, which is the personnel that occupy the facility. They move the materials, they undertake the process, they do the environmental monitoring. We have engineers coming in to do planned preventative maintenance. We have quality assurance as well, overseeing the process. So thinking about specifically the operations, then we have the way that we manage these biological entities, these materials that are coming into our clean rooms as starting materials or processing aids. So ensuring that we've got the right level of control up front before it even comes to the warehouse door is really important. We've got our approach to cleaning the facility. Again, typically, not massively different from what you would anticipate in an aseptic or sterile manufacturing facility, large or small molecule. But there are a couple of additional considerations that relate to biologics production that we'll need to take into consideration. Material movement, very important. Alongside personnel, the materials, so the raw materials, the consumables, and to an extent the equipment, all present a potential risk of allowing contamination in, or if equipment is being moved around, then the concern around the loss of containment and moving material from one room to another. Access control is really important. Considerations for access control will, to a certain extent, mitigate against those kind of human factors. It'll prevent people from wandering into areas that they shouldn't be in. It provides us an audit trail of everybody that's been in and come out of the manufacturing facility, which is really useful when it comes to investigating and root-causing issues and non-conformances that might occur. Mentioned equipment movements, and then of course we've got gowning. Again, not dissimilar to aseptic sterile manufacturing, small or big molecule. Adherence to gowning obviously is really important. So we'll touch on that briefly. Okay, facility design. So the clean rooms themselves need to be architecturally discrete, so self-contained, production environments with all necessary support areas that can operate autonomously. The best designs I've seen is where there is some form of physical separation between those clean rooms. So, for example, you might have adjacent clean rooms with an uncontrolled technical corridor running between them that will allow engineers and maintenance staff access to utility plates from outside of the clean room. So that means that considerations for calibration, maintenance, repairs can be achieved without actually breaching the integrity of the clean room, disrupting operations and adding to downtime, which we'll want to avoid as best as possible. So the design needs to be commensurate for the containment of BSL level 2 and GMO level 2 organisms. Typically, if you're looking at working with entities more exotic or pathogenic than level 2, then you enter a different environment entirely. And there's a whole raft of additional controls that will be required. For each of your discrete clean room environments, you want dedicated material and personnel airlocks, and wherever the design can be arranged as such, they are best to be unidirectional only. So there's a single route, no reversal of flows for people, waste, or materials. Clean rooms ideally need dedicated air handlers. So best way to organise this, although it's quite an expensive way of organising it, is to have the air handlers running on a full fresh air with no top-up or recirc. So single pass, in and out, no sharing across clean rooms. As I mentioned, it's always prudent to include a non-classified space between the clean room environments to really reinforce that physical architectural segregation. And we've also found that redundancy is really important, particularly when the utilities and services that are operating are integral to our containment and cross-contamination avoidance policy. If you're operating HVAC with a single fan, single inverter, you've got a single point of failure. If that goes down, you're going to have to draw a line under what you're doing, clean down and start from scratch. So in the past, we found the use of fan walls as opposed to single fans gives you a level of redundancy because the HVAC can operate and the necessary absolute and differential pressures can be maintained even if you have a partial failure of your fan wall. Same goes for UPS backup, generators, low temperature hot water generation. Because inevitably, if you've worked in this industry a while, you will know that what can go wrong will go wrong eventually, despite all your best efforts. So where you can build in redundancy, it's definitely worth doing. Okay, a few words on environmental monitoring. So you built your clean room space, you've done your commissioning, you've got your balance, you've evidenced the efficacy of the HVAC controls. You go into OQ, as you would per ISO 14644. And we found that typically under historical circumstances, you would limit your monitoring to non-viable only for OQ. We found it's really valuable to get a baseline at this point in time to do some viable EM as well. It doesn't have to be underpinned by a definitive strategy. It's just an opportunity to get a feel for what your challenge is going to be. And it gives you some reassurance that as you move into quite a convoluted and protracted performance qualification, you'll have a degree of confidence that you'll get through that without any significant problems. So when you go into PQ, you've taken the output of your OQ, you've done your smoke studies, you've done your cleanup rates, you have developed, based on risk assessment, a regime for your environmental monitoring, so you're viable and you're non-viable, and that's enshrined in your PQ protocol. You execute that minimum of 3 times, and ideally you want to do that under the most realistic conditions you can manage and make it worst case. So fully load your clean room with more than the number of staff you anticipate having to use, and either run a really realistic simulation or ideally some kind of engineering run. That way the data you get is far easier to defend to a regulator, and more important than that, it's much more representative of the challenges your clean room is going to have to accommodate. Okay. So once you're through a successful PQ, then in our experience we've found it's best to maintain that quite intensive monitoring program for a good 6 months of operation. That allows you to do a number of things. It gives you some really good baseline data. It also allows you, after that period of time, to identify and establish your factory isolates, because you're going to need those for a number of things. And another point to make, through bitter experience, people tend to be extremely sensitive to the evidence of low-level mold in their grade C clean room spaces. Now, mold is ubiquitous, it's everywhere. You're not going to completely avoid it, and as long as the levels are within your action and alert limits, and as long as the mold species doesn't suggest that you've got a potential reservoir within your facility, then it's really just a result of mold tracking in through personnel and material movements. It's undesirable, could be considered objectionable, given where it might appear in your process or where physically where that appears, but it's not the end of the world. Another useful tip, I guess, is wherever you can, keep the responsibility for performing and processing your environmental monitoring in-house. Try and avoid contracting it out. It's probably one of the most important processes that any aseptic manufacturing processes is going to need to progress with. And being able to keep your hands around that and maintain control is really important. So the actual sampling itself, the growth promotion testing of the media that you use, to do the environmental monitoring. The incubation, the enumeration, and where possible, the speciation. My organisation has made good use of the Molditov MS approach to speciation, and it's phenomenally quick. It's usually a day to subculture and grow up, and then it's a couple of hours on the machine, and you can run 96 samples in a session. So it's far quicker, far easier than sending your samples off to a third party, where you're incurring courier costs. You got either pay for a priority service, or you wait your 3, your 5, your 7 days to get your results back. This way, within 24 hours, you've got your EM results processed and your speciation completed. So there are lots of advantages, and it allows a much quicker reaction to any issues that you might find. One thing we've also found is in an environment where you've got a facility and you've got maybe a number of discrete manufacturing clean rooms, all kitted out differently, all operating different processes with different numbers of individuals involved. Being able to make a comparative assessment based on the at-rest environmental monitoring specific to a particular clean room is quite difficult. You're kind of comparing apples and pears. What we found is if you undertake a very systematic, fairly low-key and infrequent, maybe quarterly, environmental monitoring program where you apply the same sample locations in every environment, what you get is an apples and apples comparison, so you can have a lot more confidence in understanding that your clean rooms are operating effectively and comparably. And just a note around objectionable organisms policy. They can get incredibly convoluted. And depending on the approach you take, if you think about identifying specific bacillus species or specific vegetative microorganisms, then you can potentially tie yourself up in knots. At the end of the day, something is objectionable based on its nature, its proliferation, its physical location, and where in the process you find it. So we found probably the most pragmatic approach is one based on risk assessment. So you categorize the nature of the species, the level that you're seeing it at, where it is in your process, and you quantify with a score. And if you go beyond a certain threshold, that particular situation that you're looking at is either objectionable or it's not, and then you can react accordingly. That way it's a more balanced and tailored approach other than just a blanket list of organisms irrespective of what levels you might see them at. Okay. So facility monitoring, again, mentioned it at the start, really important. So we have typically a building management system that's commissioned. That's the brain of the facility, if you like. It's got all the feedback loops and controls all of the primary functionality. So your absolute pressures, your temperature, possibly your humidity as well, if your HVAC is up to doing that. And then that is independently monitored by a qualified EMS. So that's the sensors, if you like, of the facility, the eyes, the ears, the nose. The differential pressures, particularly the action and alert limits, the best approach we've found here to establishing those is based on process capability. So there is no point setting limits tighter than the capability of the HVAC to maintain within that band. If you go down that route, you'll end up with a huge amount of nuisance alarms, that people will very quickly become used to, and they won't respond in the right manner. If you do some statistical analysis and actually calculate your process capability and then set your limits, 3 standard deviations either side of the mean, you will get a scenario where the limits are indicating situations where the HVAC is not operating properly, but without a huge amount of nuisance alarms that you're obliged to react to that just basically is waste. Also, it's important that everybody gets visibility of what's going on in those clean room spaces. So typically you would have a audio-visual beacon before the personnel airlocks into the module on the other side, on the way out, and also some kind of HMI in the module itself where operators can interrogate the EMS, they can observe alarms, not necessarily to change any parameters, but just having the ability to look and see what's going on is very important. Okay, some words on HVAC and airflow. So as I mentioned earlier, the safest approach when we're looking at different processes and with different biological entities in different clean rooms is dedicate your HVAC. So you might have one HVAC dealing with your kind of non-process common areas, your CNC and your grade D spaces, your access lobbies, etc. But for the clean room footprint itself, it's far better to have a dedicated HVAC with a single pass full fresh air. And we found we get the best and most consistent control if we have our variable air volume boxes on the extracts opposed to the inlets. As I mentioned right at the start, we're trying to do two almost mutually opposing things. Classic clean room, where you're trying to keep environmental contamination out. You tend to have a higher pressure in your core and a cascade down to lower pressures as you work your way out. With considerations for containment, you typically reverse that, and you would have the higher pressures on the perimeter, the peripheral areas of the facility, and the clean room at a lower pressure. When you're trying to do both, the best approach that we've found is at every point of access and egress into and out of that clean room, you make use of either a pressure sink, so a low pressure environment that will suck air bleeding from the clean room and from the routes in and out, or you use a bubble or a hill to effectively act as a barrier for environmental contamination moving out the clean room and out of the route in. So either one works. Word of caution though, if you're going to use sinks on the routes out, you're going to need 3 discrete lobbies to make that work. We made that mistake in our original design. We had 2 and then we had to think again. Ideally, 15 Pascal differential between adjacent areas are of different grade is a good precaution. You can get away with less, but 15 accommodates for any variability in your HVAC control. Typically, HVAC is going to fluctuate 2 or 3 pascals in any direction. So you imagine a worst case where you've got one area at +3 and an area of higher pressure at less than 3, then already that 15 has been eroded down to 9. So we found 10, it doesn't give us the confidence that we're 100% going to get that differential. What we want to avoid is an equilibration or, at worst case, a reversal. So 15 is a good number. When it comes to terminal HEPAs, H14s are okay, but we would go for the ULPA filters, the U15s, because they will also reduce a viral load where the H14s probably wouldn't. I'm sure I'm preaching to the converted. Long are the days when this was done, but I don't ever think to repair a damaged HEPA. If it's damaged, replace it. And also, we see that at the end of a campaign of a particular biological entity, what we would tend to do as part of our campaign clean down and change is use vaporized hydrogen peroxide to fog the entire room. And then we would change out the HEPAs and go again. And if you're going to fog, then you're going to need slam shut gas-tight dampers on all your supply and extract ductwork, so you can completely isolate the HVAC provision to that clean room. Okay, personnel. So as I mentioned earlier, people are the biggest risk factor with regards to the introduction of contamination to your clean room environments, and they're also the biggest risk factor with regards to potential biological material moving from clean room to clean room. We, in the industry, spend a lot of time and effort training our individuals, but training can only go so far. What you want to be able to do is effectively mistake-proof as much as you can from the perspective of preventing the ability for people not to follow procedures. So, for example, dedicated keycard access control means only the right people are given access to the right areas. If you have an interlock strategy, it means that people can't transition quickly from one lobby to the next, not giving a room enough time to recover its classification. So the right interlock strategy just prevents that from happening, full stop. And there are plenty of other examples where you can work in this kind of process control. So it's not a requirement for a grade C environment to qualify your operators in their gowning regime, but it's a really good idea because it again gives you the opportunity to reinforce and contextualize the importance of the adherence to gowning. And that goes for a lot of clean room and aseptic behaviors. It's one thing to learn them, to be taught them, to practice them, to get a qualification. But without that contextual background, it's not necessarily going to stick. Okay. And then finally, another way of reinforcing behaviors and gaining a level of assurance that they're being adhered to is the concept of walkarounds or Gemba walks, where management, supervisors, quality assurance actually gown in on a regular basis, walk the walk, and observe from themselves that a compliant approach has been taken across the activity in the facility. Found that very powerful. It gives management the opportunity to understand what life is like at the coalface, and that tends to help with regards to relationships. Okay, before a biological material is even considered to be allowed into a manufacturing facility, you've got to have established a robust level of control over how you're going to deal with these things. So just like any other starting material, raw material, you need a biological material specification. Some kind of unique identifier that's present on the tertiary packaging of the material when it comes in. So the guys at the warehouse can immediately identify it for what it is. And if it ain't got the identifier on, it's not even allowed in the facility. So a material specification for a biologic entity should really start with a very detailed checklist to ensure that you are consistently gathering all the component information you need to satisfy yourself that that material is suitable and safe to bring into a manufacturing facility. So we want to understand the material type. Is it a cell line? Is it a vector? Is it a plasmid? Its intended use, its GMO class. Checking whether the Nagoya Protocol is relevant to that material. What kind of pre-screening or testing is appropriate for it. If it's a cell line, you want as a minimum sterility, mycoplasma. If it's a viral vector, you might want to add replication incompetence testing to ensure that it's not able to proliferate outside of the designated host cell. Qualification of the packaging is also very important. A check on HTA licensing and an assessment to ensure that the strategies that you have for the inactivation of biological material is still suitable. Are you going to need some fairly thorough policies and procedures? So in no particular order, a procedure around the picking, packing, and dispatch of the final product, drug substance or drug product. How we manage the transfer of intermediates during a manufacturing process. The actual storage of your biological materials in the facility. Typically that's going to be a -80 for a viral entity or vapor phase LN2 for blood products, tissue, cells, etc. And then, as I mentioned at the start, the physical receipting of that material, what checks are undertaken, what the rules are in receiving, checking, and then storing in a quarantine environment. Transfer of samples is just as important. These samples move around the common areas. If they're not handled properly, then they present a risk of a loss of containment and the introduction of that material into somebody else's process. Physically, how you get the biological material from the warehouse to the modules, so what precautions, what procedures you employ for material transfer, clean down, how long you're allowed to have that material in transit before it arrives, how you transfer responsibility, accountability for that material from one set of folks to the next. All that's really important. Management of spills, so that's really key. So the best way we've found this is spills inevitably should be a very uncommon occurrence. And as such, keeping people suitably familiar and skilled with the approach that they need to adopt if a spill occurs is very difficult. So the way we do it is we have a dedicated spill team comprised of multidisciplinary departments. So we have engineers, we have manufacturing technicians and operators, we have QC, we have QA. And if a spill should occur, then they are called upon as a team who have been practically trained and have had reasonably regular simulations, just as you would do for fire drills and evacuations. Otherwise, it'll be rabbit in the headlights and people won't know what to do. Okay, and then the management of waste is also very important. So what's your strategy for handling biological waste? Are you going to treat it separately to other clean room waste, or are you going to incinerate everything? How do you segregate and control your different waste streams? How do you select and qualify a contractor that's going to take away your biological waste and dispose of it for you? So all that needs to be taken into consideration. Cleaning, okay, so again, not dissimilar to any clean room manufacturing environment. So you establish a set of rotational cleaning and sanitizing agents, something that will also be effective against endospores and viruses is really important. So typically, you start with a neutral detergent to remove the physical soil. Physical soils potentially can partially or completely inactivate your sanitization reagents. It's so important that when you apply your sanitizer, you're applying it to a surface that has been physically desoiled. Typically for CNC and grade D material transfer and cleaning applications, you'd have neutral detergent and then an alcohol-based sanitizer, something like 70/30 IPA water. When you're moving from your grade D to your grade C, ideally you want to be using a sporicidal surface sanitizer. So something like either a hypochlorous acid-based material or maybe a hydrogen peroxide-based material. There are a plethora of choices out there and many ways of dealing with that. What I would suggest is that you always have something in your back pocket for those scenarios where you have a major issue, a contamination, a spill, etc., and you've got something that you can rely on, that you've qualified using facility-specific coupon efficacy testing, where you take a panel of challenge organisms and you physically demonstrate that you're getting the right log clearance with those materials. So with regards to material movement, quite often organisations will employ physical totes to move materials around. It's important to ensure that those totes have a specific environment from which they are not allowed to migrate from. For larger production picks, you could consider pre-kitting. So in other words, the bill of material is picked and assembled in a single tote, and then that is moved quickly through the facility. One better would be the concept of cleanroom kitting, where you have your pick actually undertaken a clean grade C environment, and that allows you then to move hundreds of small items through the manufacturing facility and into the production area with a very minimum of cleaning. And I think I've run out of time. Have I run out of time? I think I've run out of time. There we go. So, any questions quickly? No questions?